All right, we are live for day 2 of Advent the Code. We are on about 52 minutes before we start, so I'll be going through 2018 problems as practice. This here was yesterday's problem. They start off easy. This is basically one-liners. Okay, so let's do 2018 day 2. Just jump right into it. Yeah, those are not ints. Okay, interesting. We have a bunch of odd character strings with some similarities. They all start with I or U. I don't know. We'll see. It's an inventory management system. Actually, give me a sec. Let me just make sure my stream health is okay. Okay, we seem good. Okay, let's read this. We've been falling through time. Year 1518. Oh, you know, I haven't been following the story here. Chronal calibration, I see. Max, hi. Hi, welcome. Are you doing Advent Code yourself? I'm not sure either. Actually, been working on a new kind of suit that would let them fit right through tight spaces. Yada yada. They've lost prototypes design. Boxes in warehouse with box IDs. We need 2 similar box IDs. So I guess these are all IDs. You scan every box. Counting the number that have an ID containing exactly 2 of any letter, and then separately counting those exactly 3 of any letter to get some sort of checksum. Okay, so just counts that appear exactly 2 or 3 times. And then what do we do? What do we do with those? Multiply those 2 to get a checksum. Multiply those 2 counts. So the number that have 2, the number of IDs that have 2 of a letter, and the number of IDs that have 3 of a letter. Okay, no need to really optimize this. We could just, for everything, get the counts of their letters. So given a string, and it's going to be a map from character to int, group map reduce, the usual. And we'll take our input, map. Actually, we're going to want to count. So we're going to count 2 of each letter. So val, exactly 2. So we have the string, we get the counts, values.set, this is exactly it. And then val exactly 3. Okay. Yeah, so count the inputs for which in its counts value set there is a 3. And we multiply those 2. Val ends 1 equals, yep, that. 7657. Pretty easy. Part two. So, the real problem. Um, the boxes will have IDs which differ by exactly one character. At the same position in both strings. So given these IDs, these two are very close. They differ by 2 characters. However, these differ by exactly 1 character. Those must be the correct boxes. So just of all of these boxes, we have to find a pair of them that differ only by 1 character. We don't really need to do... We don't really need to do counts. I think we can just zip these two together. So we'll just do this. So what do we call that? The distance? The number by which it's like the Hamming distance, kind of. Except that's binary. We'll call it distance anyway. It's some sort of distance. Yes, that's the idea. So zip the two and then count the numbers that are not the same. Okay, that's exactly what I want. And actually, let's check out input.size. Will this approach work? Can we do n squared with 250? Totally. So for S1 in... Wait, there's already product, isn't there? And then what do we do when we have... What letters are common between the two correct box IDs? You remove the differing character. Okay, and there should only be one. I'm not even going to bother doing... I'm just going to do every single one, and we can early terminate. Let's see, if dist is equal to 1, what do we yield? I'll call this candidates. Candidates. We yield the 2 minus that letter. S1 dot zip, S2 dot filter. We want to keep the ones that are identical. Let's do a collect. Case A, B, if A equals B, just A. Yep, that's exactly what I want. And candidates, just dot head. That makes string. Okay. And you know what? I still don't know how to copy paste from these highlights. So I'm going to copy worksheet output. Okay, easy enough. I still think I spent too much time reading. I think on this next problem, I'm going to try just kind of solving it without reading. I mean, reading, but we'll go by instinct. Okay. Day 3. And let's download that. 2018, day 3. Okay, what does our input look like? Interesting. We have coordinates. So we have like an ID. We can ignore that. It seems like it's just the index. Index coordinates and an area. What could we possibly want to do with that? Okay. Chimney squeeze prototype fabric. Okay. I'm gonna skip to the question. How many square inches of fabric are within two or more claims? So each of these represent a claim. So what, we take the union? No, 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 not the union for all of these. Okay, how many are within the intersection of any two areas? So the union of all the pairwise intersections, right? Okay, so let's start by parsing this. Val, so these are claims? Yeah, equals input map. What is the collect? So case. Wait, how does it know? It knows the format. Wait, why does it know the format? Okay, how does Copilot know the format? Is it because I downloaded the file and it's in this repo? Um, is that why it knows? Okay. Wow. I mean, that's impressive. Okay. We have types for this. So we're gonna import point and area. And we're gonna make what does a point stand for? Is it the top left? About which area of fabric would be ideal for Santa suit? The number of inches between the left edge of the fabric and the left edge of the rectangle. Okay, so this would be 0, 1, 2, 3. 3 across, 2 down. Okay. Y here is going to be negative. So basically 0, 1, 2, 3. Yeah. Point x dot to int, y dot to int, to area, w dot to int, and h dot to int. And we're not going to do anything with ID. This is going to be a list of point and area. Is that a proper constructor for my area? I can't remember. It's been a year since I've used this. Oh, right. These are intervals. This is basically a set of points. So I can give, what I should do here is give the left. Um, so we have the x range and the y range. So we have x dot to int, and in this case, the top left is just going to be this point. So we don't need this. Oh, you know what? We can do the bounding box. Bounding. So val top left, val bottom right. There we go. Bounding. Top left, bottom right. Yeah, it takes 2 points. And this can just be a list of area. Okay, cool, cool, cool. Um, and just for funsies, claims.map, um, that size. All right. So I guess we could basically add, this is small enough, we can just add each of those to a scene set. And then one that, since in the scene set, then we add it to like a double claimed set. Yeah, rather than, I mean, like, I could just pairwise intersect all of these. My area does have an intersect method, but we'll do this. We can explore other ways to do this later. Um, so claims that full left, and we're gonna have two empty sets, and we don't want that. Okay, so scene and an overlapping claim. This is exactly what I was talking about. This is not exactly correct. Okay, so we have scene, we have overlap, and we have a new claim. And I guess we want claim dot points iterator dot, I guess we partition based on scene. So val new overlap if it's scene, and new scene otherwise, and then scene plus new scene overlap plus new overlap. And then val, so I guess on the left would be just everything that's been seen, so we can ignore that, and on the right would be all that's double claimed, overlapping. And then we just do overlapping that size. 121 521. 121 521. Answer too high. Okay. 121 521 too high. Let's just try this on their smaller set. So where was the problem? Let's see, val input. I'm just gonna comment this out. And it's a list of strings, so do list. Put this in here, multi-cursor, commas, great. Okay, for this we get the answer 13, but let's look at the claims. Claims for each line. Okay, 1 to 5 and 3 to 7. So 1 to 5, 3, 4, 5. Oh, I think it might be too large. So this says at the point, no, okay, 1 to 3, 4 by 4. Let's look at the area of each of these. That should be 16, 16, and 4. Oops. Okay, claims dot map dot size. Yeah, okay, it's off by one. This is why you should use ranges. Um, so -1, -1. Should have seen that coming. Okay. Um, great. So the test input we can just comment out. And 104.126. 104.126. Should have seen that coming. Okay, part two. You notice exactly one claim doesn't overlap by even a single square inch with any other claim. If you can somehow draw attention to it. Okay. So we have this full set of overlapping. So I guess for ans2, we can just find the claim that doesn't overlap. Claims dot find. Yeah, and I think we can just do dot overlap, not exists. Not okay. Ans2. They not exist overlapping. Okay, all of its points, none of its points are overlapping. So we have this one, and we need the ID of the claim. Okay, so we zip index, sort of. We do index where. And then -1. Let's just put it in right now, 693. 693, we can refactor afterwards. 693, too low. 693, too low. Okay. Claims 693. Which one is that? And we'll just turn this back to find. Yeah, okay, off by one again. I think I had to add +1 because this is one indexed. They have to mess with us. Oh, wait. No, I didn't have to change it. Do the indexes actually start? Are they 0 indexed? Return to day 3. Let's look at the input. They are 1 indexed. Okay, I need to rewrite this whole thing. I should be rewriting in such a way that we don't have off by 1 to worry about. But anyway, it's 694. Wait, it's still too low. Okay, maybe it's actually just a wrong answer. So this is the one we think it is. Index where. Okay, let's take a look at this code. So the points, there doesn't exist a point that overlaps. Let's just reverse this. For all, it doesn't overlap. I mean, that's still the same answer. Let's try this for the example. Oh, no, there is no. In the claim above, only claim 3 is intact after all claims are made. Okay. Let's try that. 5 to 6, 5 to 6. Weird. Claims 2, which is actually claim 3. Um, Hold on, we do have to subtract. Claim 3 is index 2. I mean, so, right, we add one. Did I not try 695? I did try 695, right? I should just parse the IDs along with everything. I can't remember. Okay. Oh my God. That's ridiculous. Okay. Um, yeah. Now, since my claims are all like area based, I shouldn't have to iterate over all of its points. I just forget the name of the convenience methods I made. So, contains. Yeah, I can very quickly check if we contain a point. Um, and I can very quickly check the intersection with another. See, my areas are based on ranges rather than, they behave sort of like sets of points. Um, but they're actually like an efficient encoding ranges. Mm. I mean, I guess I could very quickly just check for each basically in this implementation for each claim, we're checking all of its points. It would already be faster just to check each claim against every other point. Well, okay, how many are there? Input dot size. Oh, well, I mean in the real problem. Okay. There are 1295. We can do 1295 squared. And each of those is a fast operation. As opposed to checking, all the points of each of these. Um, well, you're checking each of those against a hash set. So arguably not faster. Input.map.size, that's yeah, so that's not faster. Do I have a fast way to check a set against? I mean, I guess I could just check the bounding box. Um, okay, so claim.overlaps. I have an overlaps method, right? If I don't have an overlaps, oh, I don't have an overlaps method yet. Okay, that might be fun. So I can do an overlap method here. One that efficiently checks if it overlaps another area, but also one that checks if it overlaps a set. Mm, not an arbitrary set. See, the problem is it's a hash set of points. And so it's a union of all the pairwise intersections. So that's not a clean area itself. I mean, efficiency doesn't matter here. But I can imagine some late game problem where it does matter, like problem 19 to 2021 or problem 21. What one of those? The reason I made this area type in the first place. Right? The fast way would be like if we turned all of these into sets, then we could check the pairwise intersection of sets. 1295 squared. That's still like, this is still like roughly n-ish. N by m, where m is like the average area. I mean, if we had smarter processing during this first bit, where we were constructing like all the overlaps, maybe. Okay, well, let's rewrite some of this. Top right, bottom right. We could also done area dot let's see, left to right x dot to int to plus the width. I actually don't like it that way so much. And this actually wouldn't have the -1 if we did it this way. Because we'd be saying until, right? Yeah. So X range, Y range. I'm not sure if I like that. I think I liked doing this bounding box. Well, let's compare the whole thing. Val X range equals val Y range. Which do I like better? I think I'm happy with either, to be honest. That's very nitpicky. I'll say I prefer the second one because it doesn't require any kind of off by one accounting. Okay, let's take out all this other stuff. Um, and it's going to be -1. Oh, no. This is a 1 plus, right? 695. Oh my god, off by ones. Yeah, it's 0 index. You have to add 1. Okay, well, we can probably do one more. Okay. Let's download that. Arrow bounce. Hello. Welcome, welcome. We are just doing some practice problems, some 2018 problems before tonight's problem drops. Oh, interesting. Okay, so we have a list of kind of state changes. Okay, wakes up, guard number whatever, begins shift, wakes up, falls asleep. Who wakes up and who falls asleep? Repose record. Okay, you sneak into another supply closet. ID the one guard on duty that night. Wait. Covering the walls. Someone spent observing this guard post. ID of the one guard on duty that night. As well as one day fell asleep or wake up while at their post. Okay, well, why are there falls asleep missing here? Asleep, wake up, asleep. 99 begins shift. So there's only one guard ever at a time. Um, Timestamps. Sure, yeah, we have timestamps. So the guards are asleep at various times. Oh, right, this is the minute and seconds, I guess. All right, I mean, so it gives you till the second when they fall asleep? No, just a minute. Okay, so this is like the first hour. So this says guard 10 begins a shift, falls asleep 5 minutes in, and then wakes up and then falls asleep again. And then guard 99 begins. But why are there multiple wake ups in a row? They count as awake on the minute they wake up. Okay. If you can figure out the guard most likely to be asleep at a specific time, you might be able to trick the guard into working tonight. So you can sneak in. Find the guard that has the most minutes of sleep. What minute does that guard spend asleep most? So guard 10 spent the most minutes asleep. Guard 10 was asleep most during minute 24. What does that mean? Like on multiple days, we're asleep during that. Okay, so there's another record for guard 10, and they both overlap on minute 24. I see. Oh, I see. The minutes here are vertical. That's what the numbers are. Your entries are in the order you found them. You'll need to organize them before they can be analyzed. Oh, okay. These are not in chronological order. Okay, so I can just give this like a lexical sort. Yes, because we have nice time formats. ISO. Yeah, and then we can parse them in groups. for each guard. And then count the times they're all asleep. Okay. We have 10 minutes. Can we do that? I think we can do at least part one in 10 minutes. We could say part two for after. Okay. We're just gonna sort now. Input. Take a look at that. Falls asleep, wakes up. Okay, this makes much more sense. Oh, guard 2803 never slept. How about that? And I guess we somewhat care about hours because we want to count like the number of minutes of sleep. So we have ranges of time. It'd be this makes me want to have like an interval that also handles ranges of time instead of just ranges of right now they handle ranges of any arbitrary like integral value. But um okay, I'm back. Let's tackle this. Uh okay, so what do we have here? So we sort these and I guess we just take until we have a guard number. So we can split them on uh let's see, parse shift. And then we have let's say we have we're gonna return some sort of shift details. I don't know what that looks like exactly. Um we'll just give that type. We'll just make it a string for now. Type shift equals string. And then we have kind of a list of times. Or no. We will have like the remaining data. This string. So we'll call this a logs here. So logs is a list of string. Okay. So this just assumes that this starts with a shift. So val. Uh, yeah, we'll just take like logs.head, or we could do logs match. So the first line will always be like the guard on active duty. So what do we call it exactly? Begin. So we have begin, and then we have what do we call these? Activity. But we're gonna do like a take while. So logs at um I don't know, we're just gonna write some spaghetti and fix things as we go. So rest dot span um not contains this character. Because that means there's a new shift starting. And this will be val activity and remainder. Not great names here, and I think I should probably rewrite this whole thing in a different way, but we can worry about that later. So we need to parse the activity. We can parse time. Does a date really matter? So what does it look like? We have this. So timestamp. And then guard ID begin shift. And then we take the activity. So we have timestamp, and we have different types of events. So there's falls asleep and wakes up. Case class shift. Okay, so shift has an ID, and then we have events. They either fall asleep or wake up, and that all has a time. And there's also gonna be a start. We'll just make the time a string for now. We don't need that. Enum event. Oh, yes. Begin shift is also an event. That's true. We can think of it that way. But I won't for now. So we'll just say asleep and wake up. Sleep and wake. List of event. Okay. And then timestamp. Oh, so these have time. 2-minute warning. Fair enough. Okay, I spent too much time reading this one. We can work on this one later. Oh, thank you, Arrow Bounce. I had forgotten to set an alarm. That should be in my go live list, but maybe it's not. Maybe I didn't go over my list. Let's get ready for today. So we had day 01, 2024. All right, good luck. We'll see you at the other end. Hey, Blue 1986. Welcome back. It's been a year. Good to see you again. 30 seconds. I have time to get water. I'm gonna get water real quick. Three seconds. Today's problem. Hello? Oh no, it's not loading. Uh, oh no, did we take down Evan the code? Uh-oh. Cool. Cool. 504. Too many scripts trying to download input. I mean, let's see. 24, number 2. Nope. Okay. Well, all that adrenaline for nothing. I know. I know. I think if we all check repeatedly, if we all keep checking at the same time. Oh, it's back. It's back. No? It's back for you, maybe. Come on. Well, I'm not going to be the one that stops refreshing. If um if you two got your problem, okay, there we go. I get my problem too. Um and let's try this again. Great. Let's look at the input day 02 2024. Uh bunch of numbers. Is it the same number of numbers each time? Nope. Maybe. Nope. Okay. The question. So, analyze this. How many reports are safe? 2 reports are safe. Safe because the levels are all increasing by 1, 2, or 3. Okay, so pairwise we check. They're safe if all increasing or all decreasing differ by at least 1 and at most 3. Okay. Well, safe. Um, so what do we call these? Levels list int. So get lines dot to list dot map. So for each of these, dot split on spaces dot map dot to int. Okay, so we have a list of lists. Great. So all either increasing or decreasing. We're just gonna spaghetti this. Or, you know, we just get the diffs. Okay, diff, or, you know, the deltas. I'm just gonna do off of input. So input.map, levels. Okay, levels dot Zip levels hill map. We get the diff. Deltas. It should just be. Okay. So a bunch of levels are safe if so either e dot for all 1, 2, 3 contains. I think I have to do this. 1, 2, 3 dot contains. Or -1 to -3 by -1 contains. Okay, how many are safe? Inputs dot count safe. This is a def. Oops. 472. I could have done that way faster. Oh no! Okay. There we go. There we go. Okay, part 2. Hey, I'm in the top 1,000. Okay, part 2. Problem dampener. Awesome name. Let's see, reactor safety systems tolerate a single bad level. Now, same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. Okay. So it's safe by removing 1. So basically, if you take a pair of them, so this is +2, -1, +2, +2, and then -1. Okay. I mean, there's gotta be a nice way to do this. Yeah, let me think. Can we just modify, can we just modify what we have? Like, is there a clever way to just check, like, all of these deltas? I could take these pairwise. So in this case, there's a single negative, right? In this case, there's a single 0. But, I mean, so this is unsafe regardless. So in this case, there's also, well, there's a single gap that's too big. Removing something is never going to fix that. But suppose, okay, let's say we have, as an example, 1, 2, I mean, you know what? If this is what we had, there's a single gap that's too big. There's a gap in the opposite direction. So if we take pairwise gaps, so this is a gap of 8 and a gap of -7. And if we smush those together, we get a gap of 1, right? Okay. So Val. Okay, so we can do kind of a dampened. Um, so what do we do here? We kind of scan until. Do we need to smush every pair of deltas? No, just problematic deltas. So if you have two in a row that are problematic, we can try removing that and recomputing. And then we just keep this same safe method, def safe with um, safe dampened. Or do we just do it within safe here? Uh, Not quite. I think we're just going to do this safe dampened. So either it's safe, and then we count the problems. So there's only going to be I suppose we look for the first problem. Well, how do we know it's a problem? Right? If you have negative then positive, is that first positive on a problem? Okay, so what are the types of problem pairs we can have? Um, so we can have 1, 2, 10, 11. This is going to show up as a big gap. So this is going to be like 8 followed by 1. 181. That is never a delta we can fix. We can basically fix it if it's a positive followed by a negative, right? That's basically the only time we can fix it. Okay, so that reduces our search space. So every time we have a positive, okay, and we know it's at least 5. So we'll look up. We'll have a backup plan here by checking. We still want deltas. B dot count less than 1. So if there's only 1 negative, okay, so if we count, there's only 1 negative, or there's only 1 equal, or there's only 1 positive. And actually, we can end that. Number that are, well, no, not quite. Yeah, we'll just do each of these separately. So let's start with the easiest case. Well, no, we'll just start with this. So if there's only 1 negative, then safe, we filter that out and the one before it. Then file I equals d dot index of index where. I'm going to rename this. So d's dot index where less than 1. Okay, so levels that split at, it's not quite that. So the we only need the deltas. We don't care about the levels anymore. So we can try two things. One where you merge it with the one to the left, and one where you merge it with the one to the right. And you know what? I don't think we even need to recompute the whole list of deltas if it's safe. We just need to check if that new number is safe. Yes. Yeah. I know, I know. Even submitting part 1, it went down for me. Okay, so you know, we're gonna do this. So these I minus 1, if this exists. Uh, so you might merge before, you might merge after. We gotta catch that if it's at the beginning. Okay, well, we'll deal with the errors later. So val after equals these I plus 1. And the before case, so these I. So this is where only 1 is less than 0. So if 1, 2, 3, 1, 2, 3 contains these I plus these before, or plus, yeah. Or 1, 2, 3 contains the after bit. Okay, and this before is just gonna be, I'm gonna turn this into Boolean. So if I equals 0, well, let's say this, I is greater than 0, and the following. So okay, so in this case, it's the before thing works or the after thing works, and after is going to be very similar code. Sure, that autocomplete is probably fine. Before or after, we are going full spaghetti. Else if, nope, the ds.count. Oh wait, if there's only one negative, this is what we might try. ds.count positive. Hold on, we should say less than 0 because we're going to handle 0 individually. Okay, if it's greater than 0, then we just flip it, sort of. It didn't flip it quite the way I wanted to. So Let's give it some guidance. Pi -1. Okay, same kind of idea. Okay, and then otherwise it's a 0 case. And if there's exactly 1 0, then it is kind of de facto safe. Else true, yeah. And this whole if else mess is kind of our backup. Um, so we just check if it's safe. Safe levels or all of this. Okay, we've gotten full spaghetti. Does it? So input that count safe dampened. Yeah, knew it couldn't be perfect first. Um, you just got syntax problems here. Which Copilot was happy to copy my syntax errors. Equals 1 or just that whole block, buddy. And index out of bounds because we have a -1. Okay, I is greater than, yeah, I must be greater than 0 so that we can check ds I -1, sure. And then I must be less than ds.length -1, so you can do I plus 1. Next out of bounds is -1 though. Oh, right. The index where might be -1. I'm just gonna lazy val this. Lazy val. Holy shit, spaghetti. Okay, so I is not equal to -1 or that. Whoops. And we do the same thing here. These are lazy vals. Okay. Okay, so we do gate it. We first check that I is not equal to -1. One, two, three contains dsi plus dsi -1 to the left. Yes, I plus 1. Okay, so I think in each of these cases we should print. So there was one negative. Okay, this should be illuminating. Right, like what's the last 6 mistakes in part 1? I didn't really have mistakes in part 1, but I panicked in part 2 and started instinctively making spaghetti. And now we have index out of bounds exceptions on really hard to follow code. Okay, so what gets printed before? Oh, nothing gets printed at all. Okay. Safe dampen, safe for all levels. Or smushing. So is smushing with the one before? Okay, is some of the two adjacent? Okay, let's see which list gives us a problem. Checking safe dampened for levels. Okay. Oh, the very first one gives us a problem. 8, 11, 14, 16, 15. So 16 here is problematic. So it should be checking index, well, in the deltas. So the deltas, in this case, there's only one positive. So the positive here is the rightmost one. Hey, good job. Good job. I think I have a strategy that works for part two. I just wrote spaghetti, so now I'm debugging index out of bound. Did the stream go down? Oh, hold up. My stream health is not good. That's probably completely on my end here. Okay, let me know if you see any issues. Okay. So these are what we're working with, and in this case, so we take this one and we try to merge it with the left and the right. And merging with the left results in a delta of -1. Wait, these deltas are wrong. Oh, okay. Yeah, so I think part one should still work if we compute deltas in the opposite direction, but part two kind of depends on that being the correct direction. Map negative. Okay, we're just gonna do this. A, B to B minus A. Okay, I don't think part one should change. Now our deltas are 3, 3, 2, -1. So we basically add these last two deltas, and the delta becomes 1. So going from 14 to 15. Great, so that's the before. So one negative at index 3. Oh, so that worked fine. Oh, hey, that fixed almost everything. So we had a problem here. -1, 1, and 0. In this case, there's only one positive, but there's only one. Aha. Okay, so only one positive isn't enough, or only one negative isn't enough, because there should also not be only one 0. So if everything else, so let's say, so the intent here is that there's only one positive. Let's just put an and ds.count equals 0 equals 0. I wonder if that'll come back to bite me, actually. Can there actually be a 0? No, I don't think that can be, because that means there's a duplicate. You have to remove that one. Yeah, so we'll just add this and on. It's not pretty, but it should work. Okay. Okay, and then, oh, so there's a new one that gave us a problem. -1, 1, -1, -3, -2, -4. Okay, so adding them turned it into a 0 in either case. So just, yeah, that shouldn't pass, right? Because we check, um, what is it again? Uh, okay, so we have one positive. This goes into the first branch, -1 to the left, -1 to the right. So when we do the one before, 1, 2, 3 will not contain that. So that's going to be false, and that's going to be false. So we had one negative at index 1, or an after. Oh. Okay, so we check to the left and check to the right. Why should that cause an issue? Index out of bounds exception. Is it causing an index out of bounds exception with the next one? If it's causing one with the next one, we get this safe dampened log here. Oh, and this should say one positive actually. And okay, there was one negative at index -1. How did we get in there? So we shouldn't have gotten into there if it's really index -1. So index where? Oh, less than 0. We want the index where it's less than 0. Yeah, same here. Greater than 0. Oh, fragile code. 1000. 1000 seems too good to be true, but let's give it a shot. Okay, input dot size. Yeah, they're 1000. It counted all of them as safe. Okay, it's because we said else true. Okay, else if ds.count the number of zeros is equal to 1, and we've already verified. Well, let's see, all the rest need to be positive or negative. And so either negative is 0 or positive is 0. So ds.count less than 0 is equal to 0, or how to complete that, greater than 0 is equal to 0. Else if true. We can just say else that. Okay. 697. That looks better. 697. Okay. 697 is wrong. Okay, so I mean it's kind of working. It's kind of working. Let's try this on test input and see if we can get that. So we'll save this as dash example. And we're just gonna run this on the example. Okay, so the count of safe for part 1 should just be 2, yeah. And the count of safe for part 2 should be 4. Okay, so I had the right answer for the example. So it's something trickier. We're in the right track, but we have a subtle bug somewhere. You regret making differences? I think I kind of too. Um, as you can see, I have uh, I jumped right to spaghetti. I don't know why. Part 1 was pretty clean. Um, I think I should just written this correctly from the get-go because I actually have spent most of the time just debugging. Okay, so we're gonna filter for safe dampened. Pair those with the deltas. Uh, yeah. Input dot filter safe dampened. And then SDs dot for each safe dampened, and we let's just do the deltas. There we go. Okay, so maybe this helps us a little bit. And maybe we can find like an obvious offender. I mean, here we take out the 40. I don't know if my answer is too high or too low. So, I mean, suppose my answer's too high. I thought something safe that wasn't. And that could be mean that my strategy just merging two deltas together doesn't quite work. What's something I could have missed? Okay, this one looks kind of fishy. 4 followed by -3. We just take out this 43. That takes out the -3. Oh, you know what? If it's the rightmost, if only the rightmost is negative, it always works. So that's an observation. Yeah, if only the rightmost is problematic, or if only the endmost is problematic, then we don't actually have a problem. I mean, I could add that assumption in and see if that changes my answer, but that's just a minor efficiency. Lucas. Lucas Zhang, welcome. Um, Lucas and Martin, you know each other. Wait. Is this like a famous Martin? Like a global leaderboard? Well, not by Martin as a username. Okay, I've got the right idea. And from here, I could either just try to debug what I have, or I could try to write it properly. And I kind of feel like writing it properly would help. 7,000th place. How many people have finished already today? I was top 1,000 for part one. I like it when I get sub 1,000. Yeah, just try removing each element and see if it's safe. You know what? You're absolutely right, God. Insight from God. I think, yeah, you're right. This is premature efficiency. I can just brute force it. This is totally a brute forceable problem. I'm gonna save this as a blueprint for making a nice version of this. We can try a nice version afterwards. But we're gonna do like a safe dampened brute forced. Safe dampened. I mean, what's the point of making a nice version if the code isn't even nice, right? We're gonna make a nice version that's also efficient, but we can do that after we just get the star. So we're just gonna reuse the safe function. And let's see, for each index, so what's this levels? List int. Okay, and then we're gonna take levels dot indices dot init. So the first few indices that exists. So for any of these indices, does there exist an I such that no, I don't like that autocomplete. It's learning off of my commented code, which is horrible. So levels dot split at I. Okay, if we split at I, is I going to be in the, let's just do a string. This is Scala. Okay, Stewart dot split at 0. There should be nothing on the left side, right? Okay. So val left and then right. You can do this very quickly. And then let's do safe left plus right dot tail. Yeah. So we either do safe levels, or there exists an index where if we split it left and right, blah, 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 and then val ends to equals input that counts safe dampened. 507, this is so easy. No, this is ridiculously easy. That took me what, like one? Oh, okay. It was easy to write. um, it was much easier to write than this, and I still have to do some debugging. But yeah, I don't know. I just didn't go brute force right away. Oh, are we still on the example? Nope. Let's check the example. 4, that's the right answer. Okay. So there's still something subtle happening. So left plus right dot tail. It should be, we check if it's safe with left and right dot tail. We could also do this by like pairing the inits with the, I don't know. there's not much to debug here. We take all the indices except the last index, and then we take the index. Yeah, we use it to split. Oh, hold on. So let's do this. Like Seward, that indices is going to be 0 until 7, right? So Seward.split at very last one's going to be 6. Yeah, I don't know why I'm taking this init here. I conflated two possible solutions I could have written. Okay, 520, that's it. Okay. Yeah. I'm just gonna remove this commented code. If I'm gonna make a nice one, it's not gonna be based on like it'll use the same idea. I don't know if it's even nice when performance is even necessary here. So val and GG, thank you. Yeah, I mean a day 2 problem, I should absolutely be brute forcing. I don't know what I'm thinking. Yeah. Oh my god, it's 45 minutes past. Let's see what happened. I went from 902 to nearly 7,000. Ridiculous. Ridiculous. Yeah, yeah. It's just a few lines changed. It's just this. It's just this. It's late. I need to adapt to the midnight problem solving. You get used to it when you get huge tickets with fairy tales. Oh, you're responding to Mux Max. I'm too dumb for AOC. I wasted 10 minutes by not reading the bolded line that you tolerate one bad level. Yeah, I know that feeling. Oh, I have spent hours solving the wrong problem. Well, maybe not hours, but I have spent a good bit of time solving the wrong problem. Um, let's see leaderboards. So I'm sure I dropped. Yeah, I dropped Gupta's in here. It's weird that does this. Okay. So what happened today? Let's look at part 1. Hey, you know what? I was second for part 1. So I'm happy with my part 1 time. I went from second to 15th. Okay, it happens. Oh, especially on the first few days, if you slip up like that, that's a lot of lost points. Mm. You did bad. Started 3 minutes late. Oh, Jet, I I wonder how long like it was a while before it was even loading. It was a few minutes in, at least a couple minutes in before it loaded for me. I think so. A couple of you in here got it to load, and I was still refreshing. And then when I submitted, I was still getting 504s. So even okay, when did I solve? 6 minutes in. Even 6 minutes in, there were still 500s. So I mean, I imagine some people couldn't even get started until like 5 minutes in. Lucas Zhang, you joined the leaderboard. Okay, let's see how you did. ZLC 1004. All right, you're at 12th right now. How'd you do today? Oh, um, Wait, have you not finished today yet? No, you have. I don't know why it doesn't show up here. Blue, you really need to get back into coding? Uh, yes, yes. Yeah. I mean, part of why I do this, part of why I do admin code and the idea with streaming is to enjoy coding again. Not that I don't enjoy it at work. My current gig is something I'm really looking forward to. But sometimes software development does take some of the fun out of coding. So things like admin code kind of bring back some of that joy. So that's why I'm here. And yeah, that's why I'm happy for things like admin code. Yeah, doing admin code with colleagues is fun. I don't know that I really have colleagues doing AOC right now. Um, but I had one a few years ago where everyone got in on it in 2021, and that was really fun. I think I'm still on those leaderboards, but um, I think the steam's kind of run out there. Let me see. So these are work leaderboards. No doxing. Uh, okay, yeah, it's not really happening. Yeah, not here either. The fun leaderboards are all the Twitch streamer leaderboards. Okay, so this, you know what? I can do one little refactor here. I think there's a cool way to do this. We could also do, um, let's see, we could do like levels dot uh, inits, and we zip this with levels dot tails. Now what that will do is just split it down the middle, sort of a diagonal. That's not exactly what we want though, because that will just create the full strings again. So we're going to do dot init. This is why I had the dot init in the indices. So this dot exists. I don't know. We concatenate them. A, B, safe, A plus B. Or you know what? We're just going to do this. We're going to map concatenate dot exists safe. Okay, one liner. So safe levels or this thing. So what was my answer? 520? It should still be 520. I don't know if that's clearer. Dot inits. Oh, let's do drop one. Oh, nope, nope, nope. Not quite. We zipped it with levels.tails. Okay. Let's moved equals this bit. And we'll just print line that. Uh, Okay. Talking about cloud and SAP integrations all the time and stuff makes me sometimes want to just go back to good old dev. Yep, I know the feeling. I know exactly how you feel. Okay, let's see what was printed here. Oh, those are iterators removed, not to list. Um, okay, let's look at that again. So 8, 11, 14, 8, 11, 14. So each of these should be missing a different one. Oh, it's getting shorter. Oh, the tails would need to be reversed. Yeah. Uh, I don't know. I like that idea, but once you start adding all the reverse and whatnot, it starts to get a little bit messier to read. So I'm just going to go back to what we had, and that's what we'll call it. Okay. Yeah, we'll see you tomorrow. And for the rest of you, if you want to stay and find someone else who's working on this, Bad Cop might still be working on this in Bash. So if they're around, maybe we'll raid them. Yeah, that's right. Okay, let's see some Bash admin code. Thanks for stopping by, everyone. Blue, welcome back. It's good to see you again. And welcome to the new viewers. T-Mux, Lupus Shang. All right, let's do this.